So, welcome back to our last recording session for Project Living World. This time it's about the scripts. So we'll have a look at each of those 6 scripts that already shown you. We'll start with the world time script. The world time script is only responsible for actually exchanging the map in JPEG as well as the clock UI PNG. And it does so if a certain time interval has been reached, and therefore you'll find 4 blocks for the 4 time intervals. These if constructions here, it's 1, 2, 3, 4, and that's basically everything the script has. It's triggered when the actual time has reached an interval that's defined here. For this time here, it's between 5 o'clock and 5 o'clock plus the time it takes to make 5 steps on the map. That's actually some kind of security window. Theoretically, it should be enough to just check for the time it takes to make 1 step, but it doesn't register every time in my testing, so I opted for a larger window here, which works great so far. Here's a failsafe check, integrated this not again. This actually is necessary because the technique for loading the new map according to the new time of day is one of teleporting the player. You can see this here to transition based on area location, is one of teleporting the player back again to the same map, to the same position he's actually on, forcing a reload of that map. This has the danger of creating some infinite loops there. For the teleporting back and forth is registered as another step by the player, and another step calls another instance of the world time script here, which would again trigger teleport and so forth. And therefore, this not again global is checked here. It is set within the right before the teleport, and only unchecked once the whole script has run through. And this way we break the infinite teleporting that would otherwise catch us here within this part of the script eternally. Okay, yeah, so it's the interval part here. Then here we just check all areas actually. So this is not only relevant for the area we're in right now, but also for all other areas. So when next time we change the area, the one we enter has already prepared the correct time. Yeah, this no warp here is something important for the creature move actual on world map script that I'll show you later on. It prevents actually all moving right after or during the teleportation process. Again, that's necessary because of the technique used here of teleporting the player back to the very same map he's on. That creates another step that the player playing the game in front of a screen will not feel, but creatures will register this virtual step, and so they would get double or even triple moves. And this no warp, which would look like warping to the player, and this no warp global here prevents these triple steps. Yeah, and I think that's here we change the clock icon. Very simple, just exchange the bitmap. Yeah, that's all that's to know about this script here. Here we update the clock and turn not again to 0. So next time it changes, it can be used again. Okay, so that's it for the world time script. Then let's go to the world time UI text script. Now what you see here, and I've done this in all of the other much longer scripts in which I can't go into the detail, I've built regions here. So this should be quite helpful to orientate yourself in the scripts. I've also done sub-regions where necessary and done lots of comments. Yeah, so this one here, for example, is called read the current time in seconds, convert to date, and store in a global int. It's a quick fix to be able to save the time. The 2-part quick fix, the other part can be found in the on module load script. Yeah. So what else do we got here? We've got show time directly on the UI clock. That's I think even from the default vanilla script here. Then define custom names for all those days, just long lists that are checking the actual date and assign it a certain string, and the whole stuff is then displayed on the UI button. Then that's the part I just mentioned. It's the display part, what does the displaying of the names we just defined there on the UI tooltip. Yeah, and this one is very important, for it calculates actually the time in the interval that's running at the moment. So as our creatures that are world time driven are moved by intervals, and how far we've progressed in each interval, and at the end of the interval will repeat their movement pattern. Yeah, it's important to set those up correctly, and this is done here for this number of total seconds. It's just starting at 0 and then increasing to finally the maximum value possible of an integer. Yeah, and therefore we have to break it down into intervals of 1 day, and we do this by actually doing some modulo calculations here, which will always return the rest of the division operation. Yeah, and this is stored then here in the global ints, and these are referred to by lots of stuff later on in the other scripts. Okay, I think that's it for world time UI text. Then it's on module load. Again, does lots of stuff. Initialize the defeated creature list once, only at the very beginning of the module, not on every reload, so it just sets this one up so we don't get any error messages as it was not found. That means it will not remember what was stored in it beforehand, before it's saved and reloaded. But that's okay, for usually deleting a creature from that list happens right after encounter, so it's just a logical second in which you cannot save, where the existence has to be persistent. This one here just prevents synchronization for world time dependent actors to take place on every step in their starting area. So it's yes, the synchronization script tries to do such synchronization actually really on every step of an actor, but only if the area the player is currently on is a different one from the area stored in the last area value. And that's the purpose of the global we are setting up here. And we are setting it up on the very first load of the module to actually name different from the starting area, so we had at least one synchronization going on there, and afterwards the current area is always stored there. Okay. Then just for loading the background image for the clock, it's standard. Initialize the time counters for the different intervals. We've seen those already. They are placed at 0 here again on module load. This is actually not a problem, because the correct values are restored a second later from the save time data, and will then be correct again. And doing initialization here will spare us to have any globals declared within the toolset or on the map. So authors will not by accident forget to somewhere initialize these values. Yeah. So here we got a quick fix to enable saving of time. Let's see. Yeah. I think this one had to do with the order, how the scripts were called, and there was a change, and I had to prevent that the initialization with a 0 value happened before the stored value could be read out, and so I only let this happen if the stored if the stored value is greater than 0. I think that was the idea here, if I remember correctly. Okay. This one now loads the map files, the JPEGs that are to be used at the very start of the of the module first time, or on load. It works a little bit different than the actualization we've seen on step beforehand. For it checks again certain time spans, but this time the whole time span. So from 5 o'clock to, I don't know, 7:30 here, from 18,000 to 27,000. That's okay here, cause this script is called only once at load, so I won't have check every second within this frame here. So I can keep this easier here. Does the very same thing and loads the correct picture. Um, for the clock here in this case, first. Yeah. I don't think we will need this for the areas themselves, for these are updated based on the steps taken with the first step you do anyway, if I remember correctly. Okay, perhaps one peculiar thing to note is that the night interval is appearing double time here. That's because we have this zero breakpoint when a new interval starts, daily interval starts, and so night is obviously before and after midnight, and so we need these two intervals here. Okay, the rest is something we've known beforehand actually. Will explain it again. Yeah, this is now some floaty stuff here. There's one floaty, or it's one local int actually existing on every creature that remembers the let me think. Yes, that remembers the time here when it has spoken for the last time, or actually the number of moves it had spoken the last time, so it can take a little pause before speaking again, and this is stored here. And one further down here, actually the text of the last floaty used by that creature is stored in a local string, and we can check against this later on and prevent a repetition of the very same spoken floaty. Okay, so that's it for our module load. And now we've one more of the small scripts. It's the end combat round script. That's very simple. The first part is some flea prevention system I've deactivated here, not needed for Project Living World. And in the second part, actually, it's dealing with entering the defeated creature into the list of defeated creatures, which then will be used by GA synchronized actors with world time CS to remove the defeated creature from all areas. Yeah, and so indeed we add a global object here to a list of creatures, the defeated creature list, and we then extend that list, which is temporarily created here. So we're reading out the existing list, throwing in the temporary list, adding something to the temporary list, which is a creature that is has been stored beforehand as potentially defeated creature. We now know it's not only potentially defeated, but actually really defeated, cause this script here and combat round is called after a battle. So we now know, okay, this creature that has been calling the battle has been stored before in another script as potentially defeated, was really defeated, and so we can enter it into the defeated creature list, which will in turn later on be used to remove the creature from all areas it might exist in. Okay. So, that's been the 4 scripts on the fly. 4 small scripts. I hope that helps in orientation, and we'll now go into the larger scripts, which I'll do in less detail, I think, as otherwise this would take 5 hours or something like that. Okay, maybe we start with the synchronized script is shorter, I think. So this one here is called every heartbeat. From the sections, I see we've first some flea prevention part. We don't need that. Then some setting up, just some variables need later on, no problem. So then the lines for actually removing a creature that lost a battle. We've just seen the mechanism how creatures are entered into the defeated creature list, and here the next heartbeat that list is red. Then if some creature is found there, then it's removed from all areas where it's stored in, and this happens here. Now these two parts here are the real synchronizing that are actually responsible for the naming of the script. The first one is synchronize world time moving active position when the player enters a map, so just on entering a map. And synchronize means here change the shown collidable properties accordingly of actors to turn them on and off. And also, of course, adjust the starting position on a map. One has to imagine that player can enter a map during every time, obviously, and this will mean for the actors that they'll find themselves in different places, potentially somewhere on their paths defined on the maps when a player enters a map. Now, not every square that a creature moves on has a defined time for it. Only the waypoints have, not the squares in between, obviously, especially as we've got dynamic wayfinding here in pathing. Therefore, the question arises where to place a creature. It's world time driven when a player enters a map. It's an easy answer. Is the time is exactly the same time as a departure time of a waypoint, then you could place a creature right on that waypoint. But what do you do if the time is not a waypoint departure time? I've decided to then move the creature ahead in its timeline, so it will be earlier at a waypoint than it might be usually, and so jump to the waypoint who has the closest future departure time, and will be placed there. It will wait then till the departure time is reached, obviously, and then move on. So again, idea is here that I don't like delays in the frames where the creatures moves, in the positions they take. Oh dear. Okay, that's the synchronizing. Just a short look how it's perhaps how it's made. So it iterates through all the creatures in the current area, then through all the props in the area, compares that if it finds a prop belonging to a creature. Then checks whether we've got a patrolling creature or a world time moving creature, which it can recognize by the local int existing on the waypoints, which is different for patrol waypoints and for world time waypoints. So if it finds that it's really a world time driven creature here, it reads out all the intervals that define when a creature has to be on the map and when not, or in other words, when its show property has to be true or false. The long conversation of time formats, I'll spare you that. It's just for breaking down actually the very abstract number of seconds in an interval, which can for intervals that are longer than daily intervals get really high and really hard to read into this 2-digit format I've described already. So you could really enter 2359 as time for begin or end of an interval, and the engine can work with it here and rebuilding such an entry back into actually seconds in that interval. Same is true for weekly intervals. Then you have 2 digits more in front, so it's 03 for Wednesday, for example. And you could also do 4 weekly intervals. I think that's just 2 more digits. So if you would something on the second week, it's 02, then 03 for the Wednesday, then 23 for 23 o'clock in the night, and 59 for 59 minutes past. Yeah, and it's the same for yearly. It's more complicated, but one can read it up then if he needs it. So that's that was a time conversion, the long time conversion. Yeah. So we read out the intervals where the creature is supposed to be on the map. Then we check the current time. Little factoring in current time per move here. Basically, we check if the current time is between one of those intervals. If that's true, we want to keep the creature. If it's not true, we will actually get lost of the creature. We want to get lost of it. So if do keep is equals 0, then we'll turn its show property to false, and also to do its collision to false, so the player does not bump into anything invisible, just in case. If it's do keep to 1, an else triggers here, and we'll make sure that show is to true. Yeah, and then we'll check if collision actually has to be set to true, and this is by the rules defined in the videos beforehand. Only then the case if actually our creature here is is an is an actively hunting creature. Only then we will have a collision property. So short break here. I just discovered the bug while explaining, so we see it's very good. It's one thing just noticed outside the project too. It's very good to try to explain things to people you usually learn the most yourself while doing so, and it just happened. So beforehand I checked here just for perception range being greater than 0 to actually set collision to true. In case we have to do keep creature, so a creature we want to have to stay on the map. This was thought too short, for I missed the second part of the expression here, which I've added now. I've also added now a check for conversation, and only activate conversation is collision. Only activate collision if the conversation check is actually set to false. For if you remember the first videos, I had explained we can also have active or aggressive creatures that will have therefore a perception range greater than 0, but actually carry no encounter directly with them that's triggered on collision. So their collision property has to be false despite having a perception range. And this special case is true for creatures that actually do have a conversation check. And this I've considered here, and now we will have only collision activated if we've got a creature with a perception range greater than 0, so it's a hunting, actively approaching creature, and at the same time it is not allowed to have a conversation check on it. For if it would have such a conversation check on it, we could have a case here of a creature that wants to talk to the player, and in order to do so in the system I have set up, it cannot have collision, or it wouldn't work as intended. Okay, great stuff here. Yeah, so I think so what happens here then is actually this is a very small and not interesting looking line, but it's totally central for everything that's happening here. For actually all those, we're in a loop here going through all the waypoint props belonging to a creature, and each of them has a departure time. And here now a comparison is done. These departure times are entered in a value called time contender, and time contender has to be a point in the future for it's used to find the next departure point where the creature is supposed to head to once the next waypoint, once the departure time of the actual waypoint it stands on has passed. And time contender so is the departure time of the next waypoint to go to, and this has be greater than the relevant actual time actually for the future point we want to go to, and at the same time it shall not be just any future point but the one closest in time. And this is why the second expression, the actual time contender, is compared to the best time contender found so far. And if it's smaller, so if it's nearer in the future but still higher than actual time past, then it replaces any time contender found so far, and so on. So this is sorting to find the best time contender. You will see some similar construct for sorting in the A* algorithm. Actually, at least I saw something there that it looked familiar somehow. Okay. And so then here, just the last area property I explained already is set now to the current area, so synchronization isn't done on each step, but only the first time we enter the area. Okay, let's close this one. Now, the last part here is to allow world time moving actors to enter and leave the map while the player is currently on the map. The synchronized step we've seen before and is for only the first time you enter a map, so what has happened while you were away. And this step here is what is actually happening while you're on the map. So as a positioning and moving of the creatures while you're on the map is not done by this script, but by the creature move on actor world map. This part here is only for handling the show property of the creatures, so the entering and leaving as it's perceived by the player. Short look perhaps. It's quite similar to what we've seen before for the synchronized part. So again, the intervals where somebody is supposed to be on the map or not are checked and compared, and find the best time contender. And we only do it for world time driven creatures, not for patrolling ones. Yeah, we now have a text hint here. If a creature actually leaves the area, the player is made aware of this. I think it's important so he doesn't think, oh, it's a bug, my creature's vanished, they're just there for no reason. Yeah. So here I think we'll have to do the same bug fix that we did beforehand. No, it wasn't the same script. Have to find it. So here, live operation while recording, totally inefficient and irrespective of the time of my poor watchers. Perhaps I cut that out. There it is. On the other hand, perhaps it's good to see this too. So yeah, take this part here and insert it here. Now we likely need to bracket more in front, or actually I'm not certain if we really need this bracket. I tend to do more than I need regularly. So yeah, no complaints. Seems the outer and the inner brackets are fine. Yeah, okay. Let's save this. Okay, good. You might you might note that this code here looks very similar to the code we've just seen above for synchronizing the position just on enter of the map and not again. This is true. It was more different with the first coding model that started. There are still important differences, so especially this check down here, which is doing this enter and leave map stuff. It's doing it only for hidden creatures, for false creatures. So it's not warping around the creatures you can already show. For we're also changing positions here. That's quite important. But I'm absolutely certain that could be coded with much less lines, which is true for all the scripts we see here. But hey, they work somehow. So last entry here is just a draw floaty method called several times. Nothing special to see here. It just brings the floaty text on screen above the heads of our creatures and is quite stolen from the script functions solutions for that. A little modified, I think, but not much. Yeah, and that's it for the synchronized script. Now only one script to go and I'm done with the videos. Oh my god. So it's now we've got the move actor on world map script. Yeah. Still called oh, in the wrong folder, by the way. Okay. Shouldn't make a difference, yeah. So it's a creature move actor on world map script, which is ticking on every heartbeat of every creature that's supposed to move. Okay, this is by far largest script with large subsections, and I've again made heavy use of regions here that hopefully help. There are also some instructions on the whole system here, and I'll add perhaps just a link actually. So I've said enough about the whole system, perhaps just a link to this one paper sheet I've made which explains the whole environment and how the elements interact. That's something I planned to originally write here. I think I'll do a link to the forum so everybody can look it up here together with the videos. Yeah. So it starts here with the no warp we've seen beforehand. So actually, if a map is reloaded due to passing of time, we don't want to get the extra steps in the process, which would look to the player like warping ahead. And so that's why the whole script basically is under the condition that we don't have the warp blocker activated. Yeah. So if that's not the case, then the script is called here. And first is a head section that can be configured by the author. So it's this one is very important here. It's actually it's a chance to speak a floaty on a turn. 33% right now. Okay, once operated with 25. Yeah. So if you want an actor who, if you think is spamming too much messages, you could just reduce this number or increase it if you want more messages. By the way, all the floaties on a certain waypoint have the very same chance of being triggered. So if you got 4 floaties on a waypoint, then each of them has a 25% chance to be triggered. But that any of them is triggered at all is defined with this number here. Then I've prepared audio clues, so you can hear them. Can hear the goblin on the second map, second room speak those, like detected or double move or something like that. I don't know exactly which I chose there. These are all defined here. You can turn them on and off or link to different files, different audio files. Actually, I tried to replace them all by floaties, but I ran into a performance problem here with some of those. No other performance problems. Actually, I don't know why this is. We'll need further investigations, but the audio clues don't do this to me. So this is just a catch here for our P4 variable. It's defined here, maximum number of rounds the creature will hunt the player. If nothing is entered, then it's assumed to be P100, so it will hunt for a very long time, if it hunts at all. Yeah, and here is just petrol mode or world time mode, it's P3. If you don't enter anything, it's world time mode. Okay. So that's the stuff more interesting to the normal player. Then lots of variables that I used in the script, defined up front. I think I'll explain just when they come further down below. So here now our dialogue system will allow dialogue with actors that have no collision. The hotfixes I just made live while I was explaining here deal with that, and also general my explanations on the collision state. Normally collisions are triggered by the engine, or other phrase it otherwise. Normally conversations are triggered by the engine when you collide with an actor carrying a conversation check to true and a conversation tag pointing at a conversation. In the system I have chosen here to prevent stuck situations, we will have collisions trigger when the actor and the player position, creature map location here, are actually on the same square, and the creature is shown our actor and has a conversation check and actually has no collision. If this is all true, then we will call here the dialogue played via script command here. Also, just in case, we store the creature carrying the dialogue in our potentially defeated creature list. I had forgotten that I'd done that already here. That's good. So it will spare the author of doing that in the conversation itself. Okay. So so this doesn't harm if there's no battle attached to that conversation. It will then just on the next battle happening override this entry here with the defeated creature, and creature won't be removed. Yes, that's true. Yeah. But if you have a conversation where actually an encounter is called from and you win that encounter, and therefore the end combat round script with its functionality of moving a potentially defeated creature into the defeated creature list is triggered, then you would have automatically already the removal of the creature dealt with. Should be quite convenient if it works out, but I think it should work out. Okay, also we've got a check here that the dialogue shall not be played again, for you can see that this exists twice, before the creature moves and after the creature moves. This is just a fail-safe check to make sure the dialogue triggers in any case, regardless of whether it was the player who moved on the creature or the creature who moved on the player. For in any case, when it's the creature's turn, it will check before it moves and after it has moved, whether it's on a square with a player. Yeah, and for situations where actually the creature remains just standing where it is and doesn't move, we don't want a conversation to have to get triggered twice, and therefore we'll have a check here that is only displayed once, set here, and it's likely checked here as a condition somewhere. Yeah, that is dialogue played this move to 0. Okay, good. So then here in the second part we have checking whether the aggressive creature has chased after player enough rounds and will teleport home instantly. It's only for creatures in patrol mode. Yeah, and will also reset any aggro counters that count actually the rounds during which a player has been chased by a creature. Better for the specific creature count the round it has chased the player. Yeah, for it's a local int on the creature. Okay, so this is what's happening here. I think that the rest will be quite understandable. I don't have to go into the details of this, I think. Okay. Then here we have the check whether the creature skips its moves this turn. It refers to the second parameter P2 above here with the minus and 100 for double moves or skipping move checks. So it's just random rolls against that number, and it's checking whether the number is negative or positive and converting that so the check works. So, well, probably a very rough solution, but it's okay. There's also then some text in informing the player if a move is really skipped and slow move a message coming in. So again, he knows that's no bug or something like that. That the creature just stands there idly. Okay. Then we've got our 3 big move blocks: aggressive move block, world time move block, and patrol move block. Yeah, world time move block and patrol move block are decided by the P3 parameter here. 1 is patrol, 0 or default is world time. And again, if we've set the perception range to a positive number and the player enters within such a perception range, then we automatically switch from both move modes into the aggressive move mode here, the aggressive mode block. So this one takes precedence and, as I said here, overrides the peaceful world time and patrol blocks. When aggressive creature spots player can escape by leaving a spot range. Lots of comments here. Creature wanders to next waypoint, or for patrolling creatures only, right back on a new by running away for a long time, then creature teleports home. Okay. So now these are complex, and therefore I've broken them up into more subsections. One of them being to manage the aggro state of the creature. So when it turns aggression mode on, and then therefore sets some variables that block the other move modes below here. And also, yeah, it's called the aggro state here. Okay, also counts the rounds the creature has been in aggro state, and these are then compared to P4, the maximum number of rounds a creature will hunt the player, and if they exceed that number, the creature will teleport home. If it is a patrolling creature, for world time creatures that does nothing. Yeah. Okay. So it's the aggro state. Then with 2 code blocks actually for the 2 moves the creature can have. So lots of repetition going on there. But if on lucky roll you get a double move, and of course the double move has to check for both squares, not only the final destination square where it lands, whether it has encountered a player there, and what does it for him. Also both moves have to adhere to rules for pathfinding and stuff. So yeah, lots of repetition. A more clever coder than me would use some internal methods here within the script and just call them. But well, I'll learn. So here's our first move then. Checking at the beginning whether we had a skip move. Seeing it here. So if you negative number for P3, I think it can happen. And it also prevents sorry, had to sort my thoughts here for a moment, so the sentence might not make the most perfect sense. So where was I? I was here with the with this condition here. Actually, it's an OR condition, so it's either skip move has to be to 0 in order to play our first move of the player, or the distance is less or equal than 1. And so the reasoning I've explained above here. Actually, it's a move shall never be skipped if the player is directly in front of the creature. So even if skip move chance was rolled above and skip move would be set to 1 here, we would still trigger the first move if the creature is just standing next to the player. So the reason is here is otherwise the player could on his turn then again bump into the creature and nothing would happen. For the encounter that's placed on the creature is only played if the player and the creature share the same square, which couldn't happen then. Therefore, the creature will, if it's directly to a player, directly placed to a player already, always approach the player and counter there and trigger there with the encounter it carries. Yeah, that's the reason here. So then comes the pathfinding for the first move. Yeah, these are calls of the pathfinding routines of the engine, passing all the relevant data needed. Just in case you have to do this sometime and you're not there listening to this, which is a very small audience at the moment, I suppose, then perhaps it's good to know for you that that actually the hero square is always the target square we want the creature to go to, and yeah. Okay. Then so this is expressed here as player position is entered as hero square, and so the creature will approach the hero here. Yeah, that's quite obvious for this aggressive move block here, but it's less obvious for those move blocks who actually are not aiming at a player position but just at a normal square position, which is true for the move blocks coming further down below in normal world time and patrol move. Yeah, then again another subsection, it's for playing creature move sounds. I haven't those in at the moment, so it's deactivated above in the header section. Because the engine does not have too many sound channels right now that can play sounds simultaneously, so we won't hear those if many of those are triggered, and also player move is triggered on the same channel, I think, so it's everything overrides everything right now, so I have it to deactivate it, but it might make sense later on to activate it, and it would be nice to hear those critters do different move sounds all around you. Should be very atmospheric. Yeah. Then here's actually the code for calling the encounter. And yes, calling the encounter is a creature on contact. So you have to be on the same square as the creature, as checked here. And also some of the prevent, flee from encounter code and stuff for deleting the creature from the world is also included here. Yeah. This is also used for calling the conversations of creatures actively seeking the party. In situations perhaps where an aggressive NPC will introduce himself with a few lines before then the battle actually starts. So first part here is the fleeing concept. It's even activated here. It doesn't harm you. So for in the relevant parts of the script, I've got it deactivating. You carry a dead weight global here. Perhaps I should comment it out. Well, okay. Yeah. Then here's the encounter is actually done here, and also it's stored in the list for potentially defeated creatures, and furthermore it's remembered that this encounter has been done once and will not be done again on a second move of this creature should such a second move be triggered at all. Okay. And again some corrections to the stuff I just said. Great that I'm so focused. So at first his comment here is old, also calling conversations of creatures actively seeking the party, is now, as we've seen, actually placed at the start and at the end of the script, not here anymore. So we delete it here, so you won't fall into the same pitfall as I've just did. So that's gone. Great. Then also encounter done works a little different, for it prevents checking for second move if the encounter was already triggered this round. So the second move will not be done anymore if the encounter has been fought, and that makes perfect sense. Yeah. Okay. And then comes the code for this potential second move, which obviously only is triggered if a second move chance is successfully rolled, checking against the second parameter here. And you see it if the encounter hasn't been already done, as we've seen beforehand. Yeah, and of course no skip move, and also player has to be in spot range. Nothing surprising there, I think. Yeah, and then it repeats basically everything we've seen above, so I'll just leave it as it is here. Okay. Then we come to the world time move block. Quite big one, quite a lot of conditions there, especially that it's not patrol and not aggressive move, no skip move rolled, and we only move creatures with a show property, no sense in moving their ghosts there in the background, just causing system resources to do so, I guess. Yeah. Some stuff for the aggro state, I will not explain in detail now, it's not that interesting. Then he finds a target waypoint. So different steps I've commented here. We'll go through all the props in the area, check whether they carry the name of the creature, check the local ints on them, and now if we find a daily waypoint, we are converting the values entered there. So this stuff here is transferring the convenient entering of 0730 for 7:30 in the morning into the seconds that are actually expressed by this through some operations that get more and more complicated for the longer you see below here for the longer lasting intervals of like e.g. 4 weekly or yearly. Yeah, and if we've got the right number of seconds, then we can actually compare it to the actual time we have right now, and again search for the best contender, as we see in another context there, and set this best contender, or its best time so far it's called here, to find the next target waypoint, which is stored here, and also store its tag. Yeah, and we do it for weekly, and then yearly. What a nightmare. I think what I've not done here is those what are they called, switch years. I think I was I was fed up at that point and was not in the mood to do that anymore, but it shouldn't make really a difference. Just hating that we have 28 days and 30 days and 31 days, and now, well, okay, we're using a normal clock here, so I did that. Yeah. Okay. Good. Let's close this for orientation purposes. Yeah. Then it's a speak floaty code. So we didn't have this before in the aggressive move mode, because there are no floaties spoken anymore. Because again, if you speak a floaty, you stop, and I did not want to have this in aggressive move mode, for it would brought have another element of total unpredictability into the chances of triggering a second move and stuff, and it's harder to balance than the movement speed if this also has to be factored in. Speak floaty. So at first we're setting up some stuff here. This time is for the pause the creature is supposed to make after it is spoken. So it's last time spoken local int is set here. Then also creature is here made aware of the speaker will let other creatures next to it properly finish before speaking. So there's some wait time. The creature will adhere to if a other creature next to it within a range of 2 squares, I think, but not the creature itself. Was a nasty bug idea for some time. Has spoken, then the time when the speaking was will be entered here. And now if we're going to check whether our own creature will speak now, we would here first check whether actually the player is in a distance of 4 squares, so you won't hear creatures on the far end of the map talking at all. It's the first check. Then it will check, okay, when have I spoken last time? So that's a break it will make between own sentences, and then it will check here, has somebody neighboring to me spoken in the last turns, and then I want to wait some time too. So if all this is true, then we will store the line it's going to speak now, and then or better not the line, but actually that's the point in time it's going to speak now, for it's speaking now, and again I mixed up something. This what we see here is not the last time spoken, but actually the string. So it's the last line spoken, and we will use it below there to actually re-roll a probability for a line to be spoken if the first roll would have led us to this line here, which we don't want to repeat. So now comes the actually rolling part for speaking. The chance is rolled here, and it's compared to the number you could define at the head of the script, or 33, and if it's lower than the 33% chance, then some floaty will be spoken, and now we have to determine which floaty actually shall be spoken, and therefore we go into all the props in the area and compare them to the name with nodes of our creature, and if we found a match there, then the creature is actually standing on the location of the prop, which also has to have the right tag. Then we're going to speak an arrived at waypoint floaty, one of the 4 that can be spoken. So at first I'm trying to find out how many floaties are used at that waypoint here. I probably did this in a quite awkward way actually. So if a user should enter something at that floaty 1, nothing at floaty 2, and something at floaty 3, I would still assume him to have used 3 floaties. Well, that's the way it's done, so please don't skip anything in between. If you want to use 2 floaties, just use 1 and 2 and leave 3 and 4 as blanks. So, and now if we found any floaties used, then we gonna do into a very, very dangerous while true routine here. So that means that quite large code block is repeated eternally until a break command is hit. And now depending on the number of floaties we found on the waypoint, we go into different blocks here. let's assume we would have found 4 floaties. Then a second random roll would be made. And it's another chance here. And so each of the 4 floaties has a similar chance to appear, 25, 50, 75, and between 75 and 100. And now, but there's checking going on here. Then actually the uh, we only get the break here that frees us of out of the while routine, and also only get actually to drawing the floaty that was rolled here if the rolled floaty is not the same as the floaty spoken in the last round. So and if it should be the same as the floaty spoken in the last round, then floaty is not printed, break is not reached, and while yeah, nothing else will be true obviously here, and while then is again called, and another random roll is made to test out another floaty here in the 4 category, and this repeats so long as it's as it's not the same floaty as was spoken in the last round. So that's a mechanism here to prevent repetition a little. Yeah. Now if we actually here's an else here. So first condition had one parameter set there, or one condition was for the first part here, that we are on the waypoint where the floaty is spoken. So it was arrived at waypoint floaty is chosen there. And now we have an else here, so it says that we are not on that waypoint actually, but now moving to another waypoint, and we'll iterating through all waypoints and compare them to the target actually we found beforehand, and if that matches and also the prop matches, then we shall go playing the moving to point floaties, and these follow the same routines as the arrived at floaties. So I'll scroll this just down here, and that's it for speaking of floaties. So let's close this region again for orientation purposes. Oh, it's long. There. Okay. Yeah, code for first move then. After we've all done this. So it's quite similar pathfinding calls I've seen above for the aggressive move mode. Perhaps one noteworthy thing here is that we are handing over the target point coordinates, not the party coordinates. For in this time the world time move is moving to just a square that has been found, but not necessarily to where the party is standing actually. Okay, play move sound is nothing new. We saw that already. Yeah, and then comes the code for a second move. Nothing special to see here. Just again checking against the chance defined at the head of the script. Good. Then it comes to the patrol move block. That's in many ways simpler. Again, mentioning aggro state, I'll skip that. Then sorting of waypoints is a little bit different here, for we don't have to handle with time and all that stuff. It's just going through actually the waypoints in the waypoint chain, and just checking where it is and increasing that number by 1 to find the next waypoint in the chain, and if it reaches the end of the chain, it will jump to waypoint number 1. So it's important to have always a waypoint number 1, and I would always have the creature placed at waypoint number 1. Yeah, and then you can't do anything wrong actually with this system here. I think it's quite self-explanatory and quite straightforward, so I think I'll just leave it to itself. Pathfinding is the same as we've seen. Play normal move sound will also be the theme, and second move is also the same as for world time. Then we go to the teleport home move. So that one is triggered actually if the counter, the max counter for numbers of round that a player is that a creature is hunting a player has been reached. So it's only for patrol mode, as stated here. And if that's the case, then it will find the waypoint with the index 1 and teleport there, including a sound clue. So that's what's done here. Here the actual teleporting is done then, so it's probably just a location change, yeah. And agro is reset, so it can all start anew. Yeah, and normal move sounds. Yeah, almost done. Here's then the second chance for playing dialogue at the end of the script, but only if it hasn't been played at the start of the script. And finally, here's just some oh, sorry, another break. That's what I get for being lazy with comments, so I've amended something here now. This last section here is actually for no warp, which is, as you remember, you can see here at the beginning of the script, is preventing actually firing the whole content of the script. We need this again because when changing maps due to time passing, we reload or we transition the player back onto the where he already stands. So we reload the map. This triggers a step, an invisible turn taken, which would allow creatures to do extra moves that look like warping to the player. This we prevent here, and now of course this prevention has to be removed so that normal moving can take place again. This happens here at the end of the script, but as the script here is called on a per creature base, actually already the first creature calling this script would remove the warp block, and only itself would be warp blocked then, but not all other creatures that come after it. And with these lines here, I make sure that only the last creature in the area's creature list, go to the count here, so with the highest count number, only the last creature actually removes the warp block. Yeah, and that's the function here. Okay, and then again comes just the standard method for drawing float text. Yeah, and that's it. That's all for the scripts. So I'm sorry that this video was especially chaotic. You see me thinking live here and fixing bugs also. But it also shows to me how important it was to do these videos, even if they've cost me a lot of time. And I think they'll be also quite important to get into these scripts in the future and actually fix bugs that might be contained in them, or actually amend these scripts to the further progress of the IB engine so that they'll stay compatible with the changing engine in the future. Yeah, thanks again for watching.